Welcome to the Deep Dive. Today, we're going to be diving into the world of photonics.
Oh, cool.
Yeah, it's really interesting stuff.
Yeah.
And specifically, we're going to be looking at frequency combs.
Okay.
And they're basically like super precise rulers for light. But the cool thing is, scientists have figured out how to make them super small.
Wow.
Yeah, and that's a huge breakthrough because it unlocks all kinds of new applications.
Yeah, like what?
Well, think about self-driving cars that can see with incredible detail.
Oh, wow.
Or robots that can perform really delicate surgeries
Oh, that's amazing.
Yeah, it's pretty wild stuff.
Yeah.
So are you ready to dive in?
Yeah, let's do it.
Okay, awesome. So what's really fascinating about this is scientists have been trying to make these miniature frequency combs for years.
Right.
And early on, back in 1993, they tried using electro-optic combs. But they ran into some problems, like with power consumption and bandwidth.
So they were promising, but just not practical for everyday use.
Yeah, it's kind of like having this amazing sports car concept, but no engine powerful enough to make it go.
Yeah, exactly. And then came femtosecond lasers and Kerr-Soliton microcombs.
Oh, yeah, those.
And while those did work, they were incredibly complex.
Oh, I bet.
And they required a ton of power. It was just like trying to power a tiny house with a nuclear reactor.
Wow. So not exactly something you could just slip into your pocket and take on the go.
Not quite. But so how did they overcome these challenges? That's the question.
Right. So there was this material called lithium niobate that seemed promising.
Okay.
But it had this weird quirk called birefringence.
Birefringence?
Yeah, it's a bit of a mouthful.
Yeah, I can imagine some of our listeners might be like, what is that?
Yeah, for our listeners who are not familiar with birefringence, it might sound like something's straight out of a sci-fi movie.
Definitely.
So can you break it down for us? What exactly is birefringence?
Sure. So imagine you're shining a laser pointer at a wall.
Okay.
And instead of seeing one dot, you see two. That's birefringence in action. It happens because the crystal structure of the material is splitting the light beam.
Oh, so it's kind of like a prism.
Yes, exactly. But not in a good way when it comes to frequency combs.
So?
Well, you need a single clean beam of light to create a precise ruler for light.
Okay.
And birefringence basically muddies the waters and limits the bandwidth you can achieve.
So it's like trying to measure something with a ruler that keeps splitting into that.
Exactly. And that's why lithium niobate, while promising, was hitting this roadblock.
Okay, so lithium niobate had the potential, but this birefringence thing was holding it back.
Exactly. But then researchers at EPFL, the Colorado School of Mines, and the China Academy of Science had a major breakthrough.
Oh, really?
Yeah, they decided to try a different material called lithium tantalate.
And this is where it gets really interesting, because lithium tantalate has 17 times lower birefringence than lithium niobate.
Now, that is a game changer.
Yeah.
Professor Tobias J. Kippenberg and his team created a frequency comb generator on this new platform, and the results were incredible.
Like, what kind of results are we talking about here?
Well, for one, they achieved a spectral coverage of 450 nanometers.
450 nanometers?
Yes. Which basically means they have a wider ruler to measure a broader range of light frequencies.
So it's like going from a basic ruler to a high-tech measuring tape.
Exactly. And on top of that, they managed to generate over 2,000 comb lines.
Wow.
Which allows for ridiculously precise measurements. And they even achieved a 20-fold reduction in power requirements.
Okay, so we've got increased precision, A&D, increased efficiency.
Precisely.
What's not to love?
Right, but here's the kicker. It's also unbelievably compact.
Really?
Yeah, we're talking about a device that can fit on your fingertip.
Hold on. I'm trying to picture this. This tiny device, smaller than my fingernail, can measure light with incredible precision, and it's super energy efficient.
You got it.
That's mind-blowing.
And because it's so small, you can imagine fitting it onto a drone for ultra-precise aerial mapping, something that was just impossible before.
Wow, so we've got miniaturization, precision, efficiency. What else makes this lithium tantalate comb so special?
Well, unlike its predecessors, it's incredibly user-friendly.
Okay.
You don't need those complex lasers and tuning mechanisms. It can operate with a simple laser diode, like the kind you might find in a standard laser pointer.
Oh, wow. So no more needing a team of engineers just to turn the thing on.
Exactly. And the best part is it operates very stably across 90% of the free spectral range.
So you don't have to constantly fiddle with it to keep it working.
Yep, it just hums along, doing its thing.
This is like the holy grail of frequency combs. Tiny, efficient, stable, and user-friendly.
It really is.
Wow. And that stability must open up a ton of possibilities for real-world applications.
Oh, absolutely. You can take this device out of the lab and use it almost anywhere.
So for our listeners out there, what are some of the potential applications of this breakthrough? What does this mean for them?
Well, let's start with robotics. Imagine a world where robots in your home can navigate clutter with the precision of a brain surgeon.
So no more bumping into furniture.
We're talking about robots that can thread a needle thanks to these tiny combs and their amazing laser precision.
So this tech could take robotics from like clumsy and cute to precise and powerful. That's pretty incredible.
Exactly. And it doesn't stop there. Think about environmental monitoring. Imagine these tiny frequency combs embedded in drones or satellites, sniffing out pollutants in the air or monitoring greenhouse gas emissions with unprecedented accuracy.
So we could have real-time data on our planet's health, all thanks to this technology.
That's right.
Wow, this is starting to sound like something straight out of a sci-fi movie.
It really is a game changer.
It is. But before we get too carried away with the possibilities, let's take a step back and talk a bit more about the science behind these lithium tantalate frequency combs.
Okay.
How do they actually work their magic? Okay, so we've established that these lithium tantalate frequency combs are pretty amazing.
Yeah.
But I have to admit, the science behind them still feels kind of like magic to me.
Yeah, I get that.
Can you, demystify it a bit? How do they actually work?
Sure. So at their core, these combs generate a spectrum of equally spaced frequencies of light.
Okay.
Imagine a rainbow, but instead of a smooth blend of colors, you have these distinct, super precise lines,
All right.
each line representing a very specific frequency of light.
So it's like a high-resolution spectrometer, but on a tiny chip.
Exactly. And the amazing thing is that by analyzing how light from this rainbow interacts with a sample, say a gas, liquid, or even biological tissue, we can learn a ton about its composition and properties.
So by shining this precisely controlled spectrum of light on something,
Yeah.
we can actually figure out what it's made of.
Exactly. Think of it like this. Each molecule vibrates at its own unique frequency,
Okay.
like a tiny tuning fork. When the light from our comb hits the molecule and the frequency matches its vibrational frequency, the molecule absorbs that specific color of light.
So it's like every molecule has its own unique fingerprint.
Yeah.
And the frequency comb is like a detective that can read those fingerprints.
That's a great analogy. And this is what makes frequency combs such powerful tools for things like analysis and sensing.
Wow.
You can use them to identify pollutants in the air, detect tiny amounts of chemicals in water, or even analyze the composition of a distant star.
That's incredible. Sounds like we're talking about superpowers.
It really is amazing technology.
But what are some of the challenges that still need to be addressed with this tech? What's holding it back from becoming as common as smartphones?
That's a great question. One of the biggest challenges is integration.
Integration.
Yeah. Right now, these frequency combs are still separate components.
Okay.
To really unlock their full potential, we need to figure out how to seamlessly integrate them into existing technologies.
So it's like having this amazing new engine, but we still need to build the car around it?
Exactly. And then there's also the cost factor.
Right.
While lithium tantalate combs are more affordable to produce than their predecessors, they're still relatively expensive.
So bringing down the cost is key to making them more accessible.
Exactly. And luckily, there's already exciting research happening in that area.
Oh, really? Like what?
Well, some groups are looking into using 3D printing techniques to manufacture the components.
3D printing frequency combs. That's pretty wild.
It is, and it could significantly reduce production costs.
So it sounds like the future of this technology is really bright.
I think so.
But how about for our listeners? What does all of this mean for them?
Well, even if you're not a scientist or an engineer,
Yeah.
this breakthrough has the potential to impact your life in so many ways.
How so?
Imagine a world with self-driving cars that can see with such incredible detail that they can avoid accidents that were previously impossible to avoid.
That's a future I can definitely get behind.
Right. No more fender benders.
Exactly.
Or imagine a world where doctors can diagnose diseases much earlier and more accurately using non-invasive imaging techniques, all thanks to these frequency combs.
So early detection, which is so important for so many conditions. It's amazing to think that this tiny device, smaller than a dime, could have such a profound impact on our lives.
It really is a testament to the power of scientific innovation.
It is.
Yeah.
It's inspiring to see how these breakthroughs can have such a direct and positive impact on people's lives.
It is. And who knows what other amazing applications we'll discover in the years to come.
That's what I love about science.
Me too.
There's always something new to learn.
Absolutely.
So we've gone from these clunky, power-hungry frequency combs
Yeah.
to these tiny, efficient, user-friendly devices
Right.
that could potentially revolutionize everything from transportation to healthcare.
And we haven't even touched on the possibilities for space exploration.
Oh no, here we go.
Just imagine using these comms on telescopes
Oh.
to analyze the atmospheres of distant planets, searching for signs of life.
You're right. The possibilities are pretty mind-boggling.
They are.
But before we launch into a full-blown space exploration tangent, I think it's time to bring in a special guest who can shed even more light on this groundbreaking technology.
Yeah, that's a great idea.
So let's welcome Dr. Alice Chen,
Yes.
a leading researcher in photonics and a pioneer in the development of lithium tantalate frequency combs.
Dr. Chen, it's an honor to have you join us.
Welcome back to the Deep Dive. We've been talking about the incredible world of frequency combs and how this new lithium tantalate tech is a total game changer.
Yeah, it's really exciting stuff.
And to help us really understand it all, we have a special guest today.
Yes, we're so excited to welcome Dr. Alice Chen,
Dr. Chen is a leading researcher in photonics.
a real pioneer in the development of lithium tantalate frequency combs.
Dr. Chen, it's so great to have you join us.
It's a pleasure to be here.
So, Dr. Chen, I'd love to hear about your journey into this field. How did you first get involved in this kind of work?
Well, it all started with a childhood fascination with light.
Light.
Yeah, I was always captivated by rainbows,
Oh, I see.
just mesmerized by how light could be split into all these different colors.
That's awesome.
And that curiosity eventually led me to study physics in college.
Okay.
And that's where I discovered the world of optics and photonics.
So you've always been drawn to the magic of light.
Absolutely. And when I first learned about frequency combs, I was just completely hooked.
What was it about them that grabbed you?
The idea of using light to measure things with such incredible precision, it just blew my mind.
Yeah, that's pretty amazing stuff.
It is.
So what specifically drew you to lithium tantalate? I mean, we've talked about its amazing properties, but I'm sure it wasn't all smooth sailing.
Oh, definitely not. Lithium tantalate is kind of a diva to work with.
Oh, really?
Yeah, it's very sensitive to temperature changes,
Oh, wow.
and it requires extremely precise fabrication techniques.
I bet.
But the rewards are worth the effort. Its low birefringence is a game changer for making these compact and efficient combs.
So you and your team really had to push the boundaries to make this happen.
Oh, yeah. It was a long and challenging process.
I can imagine.
Years of research and development to really perfect these lithium tantalate frequency combs.
So now that you've kind of achieved this breakthrough, what applications are you most excited about?
There are so many possibilities, it's hard to choose.
Yeah.
But for me personally, I'm most excited about the potential for medical imaging.
Oh, really? That's interesting. How could frequency combs revolutionize medical imaging?
Well, imagine being able to create super detailed images of the human body.
Okay.
But instead of using X-rays or other potentially harmful radiation, we use light.
So a completely safe way to see inside the human body.
Exactly.
And with incredible detail.
That's right. And this could lead to earlier and more accurate diagnoses,
Wow.
less invasive procedures,
Wow.
and potentially even new treatments.
That's incredible. It's really inspiring to see how these scientific breakthroughs can have such a direct impact on people's lives.
I agree. That's actually what motivates me and my team every day.
Yeah.
The desire to use our research to make a real difference in the world.
Well, Dr. Chen, thank you so much for sharing your insights and your passion with us. It's truly inspiring.
It was my pleasure. Thank you for having me.
Well, there you have it, folks. The world of frequency combs is bursting with potential.
Yeah.
And with this new lithium tantalate technology, it seems like we're just getting started.
Absolutely.
From self-driving cars that can see with incredible detail to medical imaging that uses light instead of radiation, the future is looking pretty amazing.
It really is.
And it all started with a simple question. What if we can make these super precise tools for measuring light smaller, more efficient, and easier to use?
And look where that question has led us.
I know, right?
Yeah.
It's amazing. And it's a great reminder that even the smallest discoveries can have a huge impact.
Absolutely.
So thanks for joining us on this journey into the mind-blowing world of frequency combs.
It's been a blast.
And until next time, keep exploring the world with curiosity and wonder.